AI is not only living in the cloud. It is plugged into power lines, transformers, cooling systems, and local utility bills. Every chatbot answer, every training run, and every video model starts as electricity moving through real infrastructure. The question is no longer whether AI will use power. The question is who pays when the grid has to grow around it. The United States already had data centers before the AI boom. But the scale has changed. A Lawrence Berkeley National Laboratory report for the Department of Energy estimated that U.S. data centers used about 176 terawatt-hours in 2023, about 4.4% of U.S. electricity. By 2028, the same report projects a much larger range, 325 to 580 terawatt-hours. Globally, the International Energy Agency puts data center electricity use at about 415 terawatt-hours in 2024. Its base case rises to about 945 terawatt-hours by 2030. Forecasts are not guarantees, but this is the important part. AI is turning data centers from background infrastructure into one of the most visible new loads on the electric system. The bill starts inside the hardware. AI accelerators can be incredibly useful, but they concentrate power and heat. A modern AI server rack is not just a computer cabinet. It can be a dense thermal problem, a cooling problem, and a grid planning problem packed into a room full of flashing lights. That is why a data center can look clean and quiet from the outside while behaving like a small industrial load to the utility. Utilities do not build wires, substations, and generation overnight. When several large data centers ask for power in the same region, the grid has to answer with interconnection studies, transformers, transmission upgrades, new generation, or demand limits. Reliability groups such as NERC have warned that large computational loads make forecasting harder because projects can appear, change size, or delay after the grid has already started planning around them. Virginia shows why this is not abstract. EIA reported that commercial electricity sales in Virginia rose sharply from 2019 to 2025, with data centers playing a major role. A Virginia legislative review found that data centers currently pay the full cost of service, but future infrastructure built for them could still raise system costs for all customers. In one Dominion scenario, typical residential generation and transmission costs could rise $14 to $37 a month by 2040. This is where the fight begins. A data center company can say it pays its own bill. A utility can say it needs to serve new customers. Regulators can say ordinary households should not subsidize private AI infrastructure. But the grid is shared. If a transmission line, substation, or power plant is built for growth, the accounting has to decide which costs stay with the large customer and which spread across the rate base. There are answers, but none are magic. Some AI companies can build or contract dedicated power. Some regions can use special tariffs for very large loads. Some data centers can become more efficient, reuse heat, shift workloads, or locate where clean power and grid capacity already exist. The best solution depends on local physics and local policy. A desert region, a hydropower region, and a crowded suburban grid do not have the same problem. AI can be valuable. It can also be energy hungry. The mistake is pretending those two facts cancel each other out. The cloud is physical. It has wires, cooling systems, land, water, backup power, and rate cases. If AI is going to become ordinary infrastructure, then its electric bill has to be ordinary enough to see. Should AI companies build their own power, or should everyone share the grid?